we talked about setting up an experimental design. How are we going to do this? Because our procedures, as you can see, sit quietly for a few minutes, feel your pulse, run in place. Well, we had already selected the run in place, but we started talking about how can you test this? What do we need to do? What are the variables? And the students would start going, oh, we can do this, we can do that, we can run in place, we can do jumping jacks. And then the class wanted to do different things. And usually it's okay for different groups in the class to do different things, but then we start talking about validity. And if we do different things, then will the data that we collect be valid? And so you can get into all kinds of rich discussion just with this simple. We were able to define the independent variables, the dependent variables, talk about setting up the testing, and talk about collecting data, and that we need to do that in an organized manner. You can't just do this on a scratch sheet of paper, because when you come back to it, it's not going to mean a whole lot to you. So I know in the new science standards we have to get them past giving them these procedures and giving them this data chart. But hopefully we've done this part to train them so that they will be able to come up with their own procedures and their data chart. So I know that that's a big push for our new science standards, is that we don't give them this information. We can't feed it to them. But unless you've gone through these kinds of practices, they won't, we have trained them to do these things. How will we do this? So, our next slide, let's find out. Yes, it is. So what we're going to do is, first we need to take our resting pulse rate. Okay, so does everybody know where to find their pulse? And we talked about we need to take our pulse rate per minute. And how can we do that? Talk about some math. We can take it for 15 seconds and multiply it by, or we can take it for 30 seconds and multiply it by 2. So that is your resting pulse rate for 30 seconds. So you can convert that to a 1-minute pulse rate. And now we're ready to find our exercise pulse rate. 1, 2, 3, go. Oh, look at Cathy and her boo. Cathy and her boo. Cathy and her boo.
Touch my toes.
You can touch her toes. You do whatever you want to.
She's like the cheese.
I know. Did you lose your rhythm with your rhythm? Is that what happened? You could try. You're moving and you're flopping. See? Everybody's happy and excited. Look at all the smiles. Nobody was smiling like that when you guys came in. That was good. That was good. If we design an experiment and we have 2 different exercises going on, will our results be valid? Share your answer with your elbow partner. Or in your case, y'all may share back there.
I think it will, because I think it won't affect it, because exercise will make it.
Okay? What we are testing is, will exercise have an effect on your pulse rate? So we need to pick how many exercises? 1. Okay, so we are going to run in place. That is our exercise of choice for our experiment today. How long are we going to exercise?
2 minutes.
Okay. Do I want to see people slowing down?
No. Go
Okay.
fast.
You need to go as fast as you can for the whole 2 minutes. Are we ready?
Yeah.
1, 2, 3, go! Guys, it has been 6 seconds. Keep going. I need to have some running action going on back here because y'all are not running. Y'all are not running. Come on, Jameson, let's go. Let's go. Okay, let's go. We can outrun you in place. No. Let's go. Look. Guys, 1 minute, 10 seconds. Let's go. Let's go. Get your blood pumping. Jameson, let's go. Oh, he's sprinting to the finish. Oh, Keenan is sprinting. Oh, okay. Time. So now, when we started to analyze our data, we used a QAR, question, answer, response. And the way that the QAR works is you have a progression of questions. And the first question is right there. You know, if you're talking about a text, reading informational text, you know, what color is the sky? And probably the first or second sentence in, there is a sentence that says the sky is blue. So it's a question that can be answered directly from the text or the data in this case. And then the next question, which our question was, what was your pulse rate after 2 minutes? And did your pulse rate increase? Okay, so now you have to think. So it's a think and search. You have to actually do some analyzation there, analyze it. And then the next question, did it take the same amount of time to return to the resting rate for everyone in your group? So again, it's not the sky is blue. You have to look at your data, analyze it in order to answer that question. So the progression of the questions, I don't want to say get a little harder, they just require different analytical skills. And the very last question, number 4, was the rate of change the same for everyone in the group? And this is where we took our data and our experiment to math class, okay? Because then we got into this big discussion about rate of change. Oh my goodness, I'm just a science teacher. What on earth does that mean? How do I find that? Who can help us? Oh, Miss Ward can help us. Yes, we'll see Miss Ward 3rd period. So all that got into that discussion, and it was really fun. But the last question, what are some factors that would lead to different rates of change for different individuals? Okay, so that is an on your own question. That's what they call it, the QAR. So could I have answered that question without ever doing this experiment? Probably, yes. So, but because I had this experience, I was better able to answer this question. So I use the QAR a lot in my classroom, and with this one, like I said, that our QAR was us actually taking data that the kids had collected and answering this type of progressive questioning. I started out doing the QAR with like the close, we went to the close reading session yesterday, and that was awesome. And so I would do a QAR with a short informational text piece as well. So that was really good, just for thought there. but there is a definite progression of the types of questions that you ask with your And here's some of the dialogue that was generated from our students.
69,
Yes, you may.
101, 64, 60.
Okay, so everybody
62.
should have 4 sets of data except for the back group that has 3.
No, 1 through 3. That means 1, 2, 3.
We have democracy up here.
2 had 2 questions?
Yeah. So I thought it decreased because it went from 91 to 52. Or did it increase? I don't know.
I don't know either.
Did we say decrease or increase since it? Because it went from 101 to 64, so wouldn't it decrease?
So that when they arrived in their math class, they had a testable question. They had their, they should have had their variables filled out. I just noticed on this one that that one did not. They should have a hypothesis. They should have data. And they easily answered the first 2 questions. You know, what was your pulse rate and did it increase? And did everyone's increase? And now we started to look and analyze the data. Did it take the same amount of time for everyone to return to the resting rate? Why do you think that happened? And then we started talking about that rate of change. So that's when they arrived in math.
Well, when they came to math, they noticed that we were in, the groups were already arranged, the desks were arranged, and they said, oh, what's our appointment clock? Are we at 10, 12? We were at 12 last time, we really need to 10. I said, we'll be in science groups today. And they're like, wait, Miss Quinn said that you were gonna, and yes, it's all connected. Oh, they didn't know we talked about anything. So they got their science groups, they were really glad. And it was nice to see that we had similar thinking on how they should be grouped, but they were grouped. And what we did is started talking about some math of what we would need to do to finish their QAR. And talk a minute about, at your table right now, what are some proportions that you are familiar with? And how can we use this in different situations, because that's what we'll be doing in just a minute. So tell your neighbors some things you would use proportions for, if you can remember. We had studied 9 in our class before this lesson. So the kids were really rich, but see if you can think of any for a proportion. I gave my students a few minutes of table talk for their group dialogue. They were able to come up with probably 6 or 7 of the 9 different uses we had been studying for them. Would you venture to say you could, did anybody think of 9? No. 8, 7, 6, 5, 4, 3, 5, 4, 1. Well, and some of them, teach math. I know, some you might not lose it. Probably math scale, percent of a number, tax tip, discount, all that stuff. One thing that I had to make sure is that they understood percent of change, and so we had to go back to make sure that they had understood proportions. And so we just briefly wrote this up there for the change, to talk about the change from the original to compare, because the QAR had them analyze, was the rate of change the same for the heart rates of everyone in their group. So quickly wrote that down, and then they calculated that, and they're like, oh yes, went through how you solve a proportion and what its purpose is.
You can, if you want to, a scratch sheet, but you'll just need this proportion, and so you'll have to do this subtraction, just like we did, over the original equals x over 100. When you go to do the next one, you'll use these 2 numbers over that original. So the original is going to change every time. Thank you.
Yeah, I know what I'm doing. Okay. Can I help you, Amber? Hang on. Mine's not the same as yours. So what? I know what to do. Mine's still wrong.
Okay. Did you subtract these 2 numbers? What'd you get? 71. Put 71 at the top.
At the top of that?
Oh yeah, you did that right. Okay. Then times these 2, and you did 4,
It's 69.
How'd you get that?
Because you use the decimals.
No, how'd you get the number? What'd you do? Tell me what you did.
Okay, what you do is you times these two like you did, right? And then x71. You divide 71 into 4. Yeah. And then I got 69. I just put 69.
What numbers do you use for 10 minutes? 52 and what?
I don't know there, because I didn't get it. Whoa. And then divide 32, 69.
32, 32. Do you do 52 and 30 or 52 and 120?
That's fair. I don't know. I just know how to do the first one. What do you put in the percent of 0 minutes?
What your answer was? You do that. And
Then what do you do for 2? I thought that was 2 minutes.
use 2, the number 2, and use that.
Oh, that's what this is for.
I don't have it for a minute right there. Well, I might. Hold on. Why am I telling you to hold on? I said I might have room right here.
You
Wait,
gotta
hold on.
subtract these two numbers. Yeah, and then after that, you subtract those two, and then after that, those two.
So you subtract these two, those two, and these two, and those.
Yeah. You get your,
Like when you subtract, what number you supposed to put up under?
your answer, which you subtract, like 47 was my answer. You put it over 169. So if you subtracted those two, then it would be that one. Those two, that one. Those two, that one. Those two, that one.
Really seemed to understand that, and they quickly were able to calculate the percents of change. And so, since the percent of change was the final use of proportions that we had, I decided to use the Freyer model. And I don't know about you, but this is the one strategy that I picked up year one that has become mine. It's not something I have to have intention to use. It's just like, oh, now we need a Freyer. You know, it's just a great strategy that we use. And for us in this lesson, the key thing for them to know, I mean, they knew that it's a type of proportion, they could list this, but right here, the non-example really showed if they knew the difference between the example for the percent of change and how to calculate it. So we spent a lot of time talking about how to write a good, bad percent of change proportion as their evidence. And this year the students really did grow in their ability to focus on that non-example as being real evidence of their thinking and understanding of this particular skill or item that we were discussing in this case. They still wrote proportions. You know, when I first started with the Freyer and in the non-example section, if we were doing proportions, they would show an example of a proportion, and over here, draw a triangle. And you'd say, that doesn't, you know, it should look on the surface to be correct, but why isn't it? And so we focused on this, and this just really gave them a deeper understanding. So that's my favorite use of the Freyer, not just as a culminating one or an introductory, but it's just a really good one.
My non-example is going to be a really bad non-example. It's going to be 100 minus 100 equals, I'm just going to go ahead and do the non-example.
Wait. What is this? What are we doing?
Definition.
Of what?
Percent rate, percent of change.
Rate of change.
What have we been talking about on our Freyer that's important to show on our non-example?
Why it's bad?
Why it's bad. Should it look like, at first glance, should it look like it's good potentially? Yeah, a good, bad example. We've been focusing on that. So on your example, you have to be very exact, but just as exact on your non-example. I think the guys, why don't you try to make a good non-example?
Make it a little bit.
And then see what we have. Should it still be a proportion?
Like 100
Yeah, it should.
minus 90.
So Khalil, can you put a little section right there and maybe do one for non-example? What you're doing something right now, okay? Doing something on non-example or characteristic.
Let's just look up the definition in the glossary. Oh, down. Purple bars, purple bars.
Here, I'll go ahead and do characteristics. Definition of rate, percent of change. Is that all?
I haven't really.
Divide. And find complete sense. What else? What are you saying? Round. Don't you have to round?
Finishes her non-example. Don't forget your equal marks.
Even though it's a good
bad one.
non-example.
I want your group to go back to number 4 and analyze the changes you found and answer the question for Miss Quinn. What, numbers 4, was the rate of change the same for everyone in your group?
No.
So look at your answers. Can you answer that together as you finish your phrase?
I won't say no. Everybody's was different because we had different percent. 3,000. X equals 3,000. That is a good, bad non-example.
You need to put like what the percent were.
Oh no, like put everybody's different percent.
Yes.
All right, so can you create a good example for percent of change? Might it?
How do you spell character?
It's on the board. All right, so who's going to do non-example?
Oh, I put them in the wrong spots.
It's okay. It's all right. Non-example. What have we been talking about as the main thing to show in a Frayer model? What is important to show in the category of non-example? No, a lot of pressure on Piper. No, a lot of pressure on Piper. What is important to show? If you're going to write example, it's important to show what it is. What's important to show in a non-example?
What is not.
It is not. Should you do something really off the law in your non-example category, like show parallel lines or something?
No.
No. So your non-example should be probably what?
X over 100, but something crazy number.
So maybe another proportion. Okay. How will you show that yours is correct and yours is incorrect if they both are going to look like a proportion?
Add the numbers instead of subtracting it, and then you can put both of them numbers on top.
Forget equal signs.
Okay. I think it would be important too to show the reader of your Frayer model that the addition or something that's incorrect. So can you make sure you notate what you did so we can see, like, hey,
We're just gonna do our own box with our colors.
the thing that I wanted the students to remember for most important point for percent of change proportion is that one subtraction calculation. Other than that, all the proportions, are solved the same way. So, they were kind of in that proportion rhythm. So I was hoping that they would say, oh yeah, but for percent of change, you have to find that difference. And so I was pleased to see some of them. This was actually their exit ticket that day. And just gave them an index card and they wrote MIP on the front and on the back, one statement. Most important part is to subtract to get your number and write, does that say it in a proportion? The most important point for me is cross products. Well, that's important in proportion. Make sure when you're writing your proportion, you put the change over the original. It's important.
So when they came back to me, they had collected data. They had answered these questions 1 through 3. And then when they came back to me the very next day, we were ready to answer questions 4 and 5. And if you remember, the QAR is that progressive step, the progressive questioning. And so number 4, was the rate of change the same for everyone in the group? Give details. So they could then, at this point, answer it was the same, it was not the same, and they had mathematical data to support their evidence, the evidence to support their claim there. And number 5, what are some factors that would lead to different rates of change for different individuals? So they really had to use their prior knowledge, their experiences. The class discussion became very rich in this segment, because they could give examples of various family members with different diseases or health conditions that also carried over into human body unit and the diseases and all that good stuff that we do for our 7th grade curriculum. So as you can see, I hope you can see that, we started out with this one simple, very simple inquiry, but it was very rich in that we used lots of strategies, and because of the use of these strategies, it expanded to various different places. And as we, I don't think so. So these are some student examples. No, everyone's heartbeat's different because no one, I can't read that, because one can pump harder. So he's given me some percentages: 50%, 30%, 39%, 12%. Doing different exercises that are harder and faster could be one of the factors that could lead to this. So they got it. They collected their data and they had evidence to support their claims. So in my science class, we always go back to that beginning testable question. I love proof paragraph. Has anybody used proof paragraph? Proof paragraph is like my favorite. It's a recipe for writing my conclusions in our labs, because proof paragraph has a very distinct recipe. Sentence number 1 of your proof paragraph answers the question or states a claim. And then sentences 2, 3, and 4 provide the evidence to support that claim. And sentence number 5 is a concluding sentence. They have to go back to the testable question and make a claim. And our original question was, will exercise have an effect on your pulse rate? So they're going to say exercise will or will not have an effect on your pulse rate. Then they're going to give me 3 supporting sentences with evidence from their data to support their claim. And then their 5th sentence in their paragraph is a concluding sentence about this experience. So that's when that question number 5 from the QAR comes in, is they could use one of those things that they learned as their conclusion for that.
together with this? Did you have to stop what you were teaching to go help with this and then go back to what you were teaching?
I just finished my proportions up. I mean, I was actually ready for that, and I delayed by a couple of days teaching the percent of change, just so that it would be
Ready
there's
for
the
what?
timing for that, and
Okay.
so we have another activity. But really, she just said, I've got some things coming up, and we want to do something together. And I said, well, I've got to do percent of change, and that's all I said. And she said, oh. And then she just said, how about and I've done this lab before, and so we just kind of coordinated it that
So
way.
you rearranged all what you were going to do just to accommodate this?
No, well, I wouldn't say rearranged because I was still in the proportions unit, and it was
But
just
if
time.
you were not, what I'm trying to say is, if you were not there, would you have still stopped and then go back to this just to help with that? Because that's the problem that we get a lot when we are trying to work with another teacher.
Right.
And
Let me say that I would. I know not everybody
yeah, there was
is comfortable doing that, and sometimes it would be harder for me to do that than other times. But I would do that because it would validate what I'm always telling my students is the reason you have math is to do the science. And that's, if you get a mathematics degree, guess what it is? A Bachelor of Science. And I go science, because, why do we have to do it? Because you have to know it for, and that science. So I want them to see me in that flexible role, because that is what I'm here for, is to have the math is just how to do calculations and understand them so that they can apply and understand bigger things in life, which are all the science stuff.